Okay, so Teleport, be great to start just with a little bit of background on the company, how long it's been around, any sort of key milestones to date. Yeah, just what you can tell us about it.
Absolutely. But maybe I should also introduce ourselves. So what is Teleport? What is it that we do? So Teleport is an infrastructure access platform. What I mean by that is that we provide on demand the least privileged access to infrastructure. And that access is built on the foundation of identity, security, and zero trust. So that's our kind of basic platform that we're offering. And on top of this, we also offer two products to govern identities and also govern policy. So policy and identity governance are kind of two add-ons. And when I say infrastructure access, I mean we control access to data centers, cloud environments like AWS, Azure, GCP, but also everything inside of them, things like servers, databases, Kubernetes clusters, internal web applications, essentially everything that engineers need to be productive. So that's what we do. And the founding team of Teleport, we came out of hyperscalers, companies like Google, Facebook, and Rackspace, organizations that manage servers by the millions. So and back then, we noticed that the way we do infrastructure security and infrastructure access is much more advanced than the rest of the world. So we started this company to bring that difference to everyone. So, and that happened in 2016. That's the first version of Teleport. It was released. It was an open source project for a long time. There was no price tag. Anyone could just come and download Teleport. So it was kind of naturally growing in popularity. And then we made a commercial offering. So we've been, in terms of milestones, so we've raised was it 3 rounds of funding. We've acquired a lot of customers. Teleport now is eligible for to be considered by analysts firms like Gartner for their quadrants, because we now have plenty of revenue to support that. In the latest valuation, the company was about like $1 billion. So we're not like a tiny upstart anymore. So we have established our kind of brand and presence and our unique approach to protecting infrastructure, specifically on the access control side.
Okay, yeah, and perhaps you can give us an overview of the Teleport zero trust approach. Obviously, zero trust as a term has been out there for a while, but be good to understand what it is that you do differently and how that distinguishes yourself from various other offerings that might be out there.
Sure. Maybe we should define zero trust a little bit better, because the term it's incredibly popular concept, and it's now been thrown around for like in many different contexts. So when we talk about zero trust, specifically what it means that you have your computing resources, you have things like web applications, for example, and people need to access these web applications. So zero trust essentially says that that computing resource should never accept network connections from untrusted parties. It means that every connection needs to be authenticated. So someone needs to log in, essentially. So every connection needs to be authenticated. So the identity of a person who's accessing is always known. And it also allows like that connection also needs to be encrypted. And the interesting concept, again, it's a very simplified explanation of what zero trust is. But the concept, if you think about it, it essentially means that network itself is always untrusted in a zero trust environment. It means we don't trust people just because they are on the network. You know how in the movies, like they would sometimes, oh, like hackers are penetrating our networks, they're already inside. Well, zero trust says it's fine. Networks aren't meant to be secure. It's the computing systems that need to be secure. So zero trust assumes that there are always hackers in the network. That's why it says don't trust anyone. One maybe example of a true zero trust system that everyone is familiar with would be an iPhone. We all have iPhones. iPhone is not very different from like a server in a data center. But your iPhone is actually very secure, even though it's not behind a firewall. You're walking with your iPhone in open world. It has an IP address. You're not protected by a local network. There is no perimeter around you. And the reason why your iPhone is secure is because of a zero trust implementation. So your phone only trusts authenticated known identities. And in this case, that would be Apple. So when Apple pushes software update to your phone, it does that through a zero trust mechanism where iPhone has an identity and also Apple itself has an identity. So that identity is backed by a hardware implementation. So your phone has a secure enclave on it called TPM, Trusted Platform Module. So that's the physical identity of your phone. And on the Apple side, they have something similar that provides identity to Apple systems that are pushing updates. So that is a zero trust implementation. Now, specifically what Teleport brings to the market is the following. Notice that when I was explaining the concept of zero trust, I use word identity a lot. Because you cannot be authenticated unless your identity is unknown. Like you cannot be a guest. Like you need to have an identity. And when you look at the state of computing today, what is happening in data centers and cloud environments, there is a lot of anonymous actors in those systems. Not everything has an identity. And even when those identities exist, they are siloed. Let me give you an example. So if you have an organization that has a bunch of engineers, so obviously these engineers have identities, and you're probably using identity platform for those engineers. But that identity platform only knows about identities of people. It doesn't know anything about identities of servers. That is another silo. So then you need to go and purchase a machine identity solution to keep track of identities of all of your servers and your virtual machines. But that thing doesn't know anything about humans. You see, now you have this kind of two sources of identities. Moreover, engineers, they use laptops, and laptops have identities too. And in this case, you need to buy another system, kind of endpoint management solution to keep track of all of your laptops. Now you have three sources of identities. And that can keep going, by the way. There are other identity silos. So now if you have these silos of identities everywhere, it is impossible to implement zero trust across all of them, because zero trust says that you need to authenticate. But if you don't have all identities in a single system, how can you do authentication? So you can't. So this is why all existing zero trust implementations, they're limited. They are usually operating within a scope of a silo. So for example, the most common kind of zero trust implementation is that, hey, you have internal web application and humans are accessing that application using a browser. So you could implement zero trust approach in such context, but it's only identities of humans who will be accounted for. But that very same application, when it's accessing its own database inside of a data center, there is no zero trust. Because remember, because your zero trust solution doesn't know anything about identities of the machines. So when machines are talking to each other, zero trust essentially is violated. And the difference that Teleport brings, even before we begin talking about zero trust, is that we consolidate identities of everything in one place. So Teleport knows everything about identities of your engineers, the laptops they're using, the servers that they have, or virtual machines in data centers, Kubernetes clusters and microservices and databases. Identities of everything is well known to Teleport. So therefore, we could implement what we call Zero Trust Plus or Deep Zero Trust, which means that all connections inside of your data center are always authenticated and encrypted. We could do that because we are the only system that keeps identities of everything in one place. I've been talking for a while. I'm just going to stop there.
No, that's all right. No, it's fascinating. And perhaps just widen the conversation a little bit and more generally, be good for you to explain why you think zero trust is so important. Because again, it's a term that's been bandied around and everyone sort of talks about it. And also maybe how it's evolved since, when it was first introduced as a concept to where we're at today. Because, as I say, it's been around. Has it evolved over time? And just, why so important?
So let's actually maybe go back in time, like a little history lesson. How did zero trust come about? Like, why do we even have this concept? Why did we have to invent it? What was broken before zero trust? So I think it's worth mentioning that there are roughly, again, I'm simplifying here, two ways to hack into someone's infrastructure, into someone's data center. The kind of two classes of attacks. One is you are attacking vulnerable software. So someone is running an application that's vulnerable, it has a vulnerability. Sometimes these things are called zero-day exploits. It means that this vulnerability is not known to anyone, hasn't been known, and the hacker is exploiting vulnerable software to get in, to kind of break through your defenses and steal your data, or maybe launch a ransomware attack. So those are, like, we could call them malware attacks, where like software is used as a weakest link to get in. So to protect against those, the industry has been getting better and better and better dramatically. So these capabilities are now like a very quick patching is built into all operating systems. Everyone is now using solutions that detect vulnerabilities. So it's getting harder and harder for an attacker to break through defenses by exploiting vulnerable software. It's just getting more expensive. And the second class of attacks is when you recognize that the weakest link in your defense is a person, a human. And unlike software, humans we cannot be made more reliably. We are the way we are. Like humans we can rely on ourselves to constantly be making mistakes. We make mistakes. Sometimes we could just misconfigure something. So now you have a system that, because of this incorrect configuration, is insecure. Humans can obviously open like wrong attachments. We could click on wrong links. We could do a lot on our computer by mistake that would lead to us getting hacked. Humans are vulnerable to phishing. So this is when you get an email that pretends to, it tricks you into thinking that you're interacting with someone who is not what they claim they are. Now it's actually getting into phone calls and SMS. So it's not just email. There are all kinds of different ways how attackers are tricking humans and committing mistakes. So that class of attack is called an identity attack. Okay. And because it's easier now than malware-based attacks, so now we're now seeing over 80% of all successful attacks and breaches, they are identity attacks. Okay. And let's zoom into what actually happens during an identity attack. Well, first, the attacker simply needs to wait for you to make a mistake, or maybe trick you into making a mistake. So you will do something that would allow attacker to get into your laptop, for example. And what attacker does in this case, it's trying to get some kind of secret, some kind of credential that they try to steal from you. It could be an API key or a private key or a password or a browser cookie. So they will use that information later to get into your infrastructure. And once they get in, they will try to pivot. They will try to go from one adjacent system to another. They will try to get into devices or computing resources on the same network. So are we following the sequence? So wait for human error or trick human into making a mistake, exploit that mistake, steal some kind of secret or credential, use the stolen secret credential to get into a data center, and then in the data center pivot from one system to another, which is also called sometimes blast radius, kind of grow blast radius of your attack. Now, why zero trust is important? Zero trust basically says, well, it seems like it's inevitable that humans will make a mistake because humans are humans. Like we cannot, especially as you add more and more people in the organization, the probability of one of them, just one, making a mistake kind of keeps going up and up, more people you hire. So which means that eventually someone will get in through a compromised person. And zero trust now prevents that attack from pivoting, from expanding the blast radius, because all other systems in your data center, remember, if you have zero trust implementation, they don't trust anyone else. Just the fact that you're now inside of the perimeter does not give you any privileges internally, which means that sure, if you hacked a single person, you will be able to access the systems that that person has access to, but nothing else. But if you didn't have zero trust implementation, in this case, it's more kind of traditional approach. The traditional approach says that the perimeter is providing us with protection, and everything inside of a perimeter trusts each other. So you can have all these databases and computing systems and Kubernetes clusters, and all of them are talking to each other, and they trust each other because they're on the same network. So if an attacker gets into an environment like that, they will obviously easily infect everything and will get access to everything. But in a zero trust system, perimeter doesn't matter. So therefore, that attacker cannot grow. The footprint or kind of blast radius of the attack does not grow.
Okay,
that's kind of where it came from.
Yeah. And I mean, as if life is not complicated enough where we are now, we're obviously on a bit of a tipping point with AI. The sort of AI explosion is about to happen. Obviously, generative AI is out there, but there's much more serious AI applications as well coming along the way. So I'm just wondering how or what the impact will be in AI in terms of the idea of zero trust. What does AI change, if you like?
It's going to have a massive impact. Now I'm actually kind of glad that I explained the importance of zero trust through the lens of kind of how identity attacks are usually unfolding. So remember, I said that it always begins with a human error, human doing something they're not supposed to. That's the precondition foundation of almost all identity attacks, and that's what AI could be used to exploit. Let me give you an example. Let's just say you are working in an organization, like a company, like mid-sized company, that is now being targeted by an attacker. And let's just say that you, like maybe you had an all-hands meeting, right? Where like the management of the company said, hey, we are opening new office in London. Or maybe they're saying something like, hey, we are making changes in our compensation, or we're making changes in our like a time off or holiday policy. Kind of same like company-wide announcement, right? So you have your employees kind of listening, getting this information, and maybe some of them are sharing bits and pieces of it on social media, okay? Now imagine all of your employees then getting a phone call from their manager, where the phone, like it's actually voice of their manager, and the manager is following up with them on the policy that was just announced. It's like, hey, and by the way, we indeed opening office in London, which you be considering moving. So now you're instantly trusting your manager, right? Because your manager is the voice of your manager, and they're talking to you about this announcement that you just heard. So like you have all your guards down, like your guard is down. And then at the end of the conversation, manager might ask, hey, by the way, can you do me a favor? And then like they will ask you to essentially make a mistake and like maybe share your credentials or something. Of course, you will not suspect anything because you just went to an all hands meeting. Then you had a conversation with your manager on the same topic. And then at the end, you're just doing them a favor. And guess what? All of this could be just scripted now. Because you could have AI agents that monitor social media of your employees, so they get all this information about the announcement that was just made. So then, like, the AI agent can make a phone call pretending to be a manager. But the craziest thing is that you could do it at scale. So essentially, every employee gets that phone call, because a script doesn't care if it's making a single phone call or it's making 1,000 phone calls. So which means that these sophisticated attacks that have full context and they can mimic behavior of a human being, like where in the past it was maybe something that only state actors could afford. Now you will have teenagers doing it for fun. That's what generative AI is going to do to cybersecurity and to identity attacks in particular. So that is why implementing zero trust is now of paramount importance, because most organizations have not. We've been talking about zero trust for many years now, but it's quite challenging to actually implement it in practice. So this is why more and more organizations are now going to be vulnerable. And this is already happening if you look at the stats. So, so the frequency of successful breaches is on the rise. So cybersecurity industry right now is generally losing. So we're in a losing streak. So we need to turn this around.
Okay, so I mean, clearly the AI is there for the bad actors, but I'm hoping as well that along with the zero trust sort of concept, AI can be used, alongside zero trust to actually help improve or provide trust in generative AI systems. So can you talk us through how AI works for the good, if you like, as well as how you've explained, the ways in which it will be exploited?
So, so this question of will we have AI fighting AI is actually a very popular one. So I'm a cybersecurity person, and I get this question all the time. And I understand it's a very appealing question. Like essentially, you have two robots fighting each other. One is trying to attack you, and the other one is fighting on your behalf, trying to protect you. So that sounds like a Hollywood movie script. However, I would say that's one of the three possible things that could happen. And maybe it's not the best thing for you to happen. So let me kind of unpack that a little bit. So remember, I said in the beginning that identity attacks are usually built on the fact that an attacker exploits human behavior and then steals their credentials, and then they use these credentials to get in. And this is where supposedly we expect like AI fighting another AI to take place when someone is trying to use stolen credentials. So I would say that the first thing we need to do in a cybersecurity industry, and this has nothing to do on deploying kind of defensive AI, is to move away from all forms of secrets and credentials for protecting information in general. So here's what I mean by this. Like today, attackers, using AI or not, at the end of the day, they want these credentials. They want your password, they want your private key, a session token, browser cookie, they're all like API key, there are all kinds of secrets. In the industry, historically, they've been trying to protect these secrets by rotating them, changing them, encrypting them, basically hiding them. But the fact that you have the secrets, that makes you vulnerable because you cannot protect, again, against the human behavior. Like someone will share the secrets, someone will leave them unencrypted, managing and rotating secrets actually very expensive. And there's also a window when you expose, even when you're rotating your secrets. So the first thing we need to do is to move away from secrets, from any kind of secret information. Because in this case, attackers will have nothing to steal. Like they will impersonate your manager, they will get into your laptop, and then what? If your laptop has no secrets on it, they will not be able to advance any further. They're going to be just basically stopped there. What are we proposing to replace secrets with? So at Teleport, Teleport, first of all, internally does not use any secrets anywhere of any kind. Instead, we rely on what we call a physical world or identity backed by physical properties of humans and machines. So for example, when a human is accessing like some system in a data center using Teleport, so the access is granted or denied based on a combined identity of human like through biometrics, but also physical identity of a laptop, because laptops have TPMs or those secure enclaves. So you combine the two. That is an identity that cannot be impersonated by an AI. Like there is no secret here. It's like the secret is there, like your fingerprint or the TPM on your machine, but those secrets are not accessible to software. That's not information that you can upload and download and copy or steal. It's a physical world. It's a technology based on physical world principles. So software cannot do anything about it. So this is how you could defeat AI very, very early on, by moving away from credentials, from all forms of secret. So that's one thing that I believe we should all start with. But that is not enough, because you should always be kind of implementing the principle of defense in depth. The second thing you need to consider is that we need to reduce the frequency at which humans actually need to access systems in a data center. I know it sounds kind of counterintuitive. It's like, well, aren't we building all these technologies and deploying them into the cloud to deliver value to our customers? Yes, this is all true, but let's not do it manually. So when you have an engineer who needs to log into a database in production, that shouldn't be happening. Like all of these things should be automated. Engineers should just write some code, push this code into a source repository, and then your infrastructure needs to deploy and run this code by themselves. It needs to be done automatically. But unfortunately, because the level of automation today is not high enough, we unfortunately, we still have engineers logging manually into infrastructure, accessing things, doing things. So they kind of they're making you vulnerable because, again, they could make a mistake, their credentials could be stolen. So the second thing we need to do is just try to minimize that practice. But people would always push back and say, hey, like we don't have technology good enough to completely automate everything. And now I could say, hey, now we do. Now we have AI. In other words, I would suggest organizations to start considering to implementing AI more and more heavily on their DevOps teams to minimize human involvement. Because in this case, you can tell your AI, it's like, hey, go and deploy the latest build of my application. And your AI will know that, oh, I need to go and engage CI/CD pipeline. And so essentially you're removing human completely from the access loop. That's the second thing I would encourage us to use AI for, essentially to automate infrastructure operations and infrastructure management. I know it's a little bit boring. It's not as exciting as having AI fight AI, but I do believe all three things need to take place. So first one, get rid of all the secrets and credentials. Second, automate infrastructure operations using AI. And then finally, we get into the kind of final application of AI. This is where you have one AI kind of against the other. So what I mean by that is you, like most organizations today, they use systems called SIM, Secure Information Management. I'm sorry, Security Events Management Systems. So essentially, when something happens anywhere in your computing environments, you get the security alerts and events, and they all get collected in one place. And this is where you can detect anomalous behavior. So for example, you might have a human who just suspiciously quickly clicking buttons at a speed that's not even possible with a human. Like humans cannot do things that quickly. So maybe that's not a human, maybe that's a robot, maybe that's AI pretending to be human. How do you detect that? Manually, you can't, because you will have to watch a lot of, there are thousands of events probably happening per second. So that's what AI can help you do, is to detect that there is something unusual happening on your infrastructure. But I do want to emphasize that's probably the kind of last thing you need to be worried about. Getting rid of all the secrets and credentials and removing humans from accessing production environments. Those two, I think, are way more important than the kind of anomalous detection capability.
Okay, and in terms of yourselves, it'd just be good to understand. I mean, are you using incorporating AI into zero trust solutions? Are there any examples you can share where that's happening?
Yes. So first of all, teleport, as I said earlier, it allows you to do probably the most important thing, to get rid of static credentials and secrets on your infrastructure, making it vastly less likely that a rogue AI will get in. But in terms of automating your infrastructure operations, so we're now like, you know how there are products like Copilot, like coding Copilot solutions that help developers write code quickly. So to help our customers automate their infrastructure operation, Teleport also includes, let's just call it like Copilot capability, but on the DevOps side. So essentially, instead of logging into servers manually to basically find some information like how much free hard drive space I have on a particular box, you can just ask Teleport, hey, how much free storage capacity I have in production on this particular server. In this case, you're speaking to a robot, and Teleport will go and will do that for you, and it will just return you that information. So that allows you to have, again, fewer instances where engineers manually logging into infrastructure. So we have that capability added. And additionally, and this is maybe more on the productivity side, we believe, and this, by the way, has nothing to do with cybersecurity, but we believe that AI should be implemented pretty much into every piece of software, even if for its capability of providing additional user interface. Just imagine you learning or exploring new software tool. Doesn't matter what that tool does. It could be an image editor, or it could be complex kind of DevOps monitoring solution. So that tool has a lot of features. So it has menus and options and settings, and it will probably take you sometimes months or maybe even years, if it's a complicated piece of software, to discover all of its capabilities. But if it has a built-in AI, you can talk to, you basically can say, hey, here's what I want to do, how I do that. And the AI will basically show you. It will accelerate learning effectively. It will show you how to do something in this tool. And so we have a solution built into Teleport as well, where instead of clicking on individual buttons, you could basically just say, hey, Teleport, I need access to this particular Kubernetes cluster. And Teleport will figure out like whether you should have this access or what conditions are missing. So that allows people to much like get things done much quicker, because you don't want like the tool itself to get in the way. Generally, you probably don't want security to get in the way. If you should be getting access to something, you should probably get it instantly without being overly inconvenienced. So we use AI for that as well.
Okay, and in terms of just again back to the zero trust, it'd be good perhaps to understand, or if you can just re-emphasize how important, I guess, it is in terms of ensuring a robust or even an optimized security environment for end users. So I guess another way of putting it is that if you're not following a zero trust policy, implementing it, you're never going to get to where you need to be security wise. Is that fair to say?
Yes, yes. So if you are unable to implement zero trust, essentially what it means that the consequence of a potential attack is going to be extremely high. Like, I don't want maybe to oversimplify or overgeneralize. It's always tempting, but when you're talking about complex and nuanced subjects such as cybersecurity, like sometimes like you have to simplify and generalize. But remember, zero trust by itself, it does not prevent you from getting hacked. If I go back to this kind of story of how identity attacks are usually unfolding, like an attacker will trick you into making a mistake, and they will get into your laptop, and now they are you. They can now pretend to be you because they've gotten onto your laptop. They essentially have access to your identity. But what zero trust prevents them from doing, it prevents them from becoming someone else. So which means that if I hacked you, like I can be Philip and I could get access to all the systems Philip has access to, but no more. That is what zero trust provides. It shrinks the blast radius. So essentially it ensures that only a single identity is compromised. I guess what I'm saying is zero trust by alone is not enough. Because imagine that I've gotten into your laptop and your organization uses zero trust, but what if you have admin level access to everything? In this case, zero trust becomes kind of defeated. It's pointless because just using your identity, I can just go and access absolutely everything. So that's probably the biggest thing, that zero trust by itself is not guarantee. In addition to zero trust, you need to make sure that people, humans, or identities, they have minimal required privileges. That's another a capability that Teleport brings. Essentially, we believe that in a steady state where nothing is happening, like all the systems are operating normally, in such a steady state, no one, not a single identity, should have access of any kind to anything. In this case, when someone hacks into your laptop by stealing your credentials, they will discover that they just get access denied to everything. So then the question is, how do you operate in such environment where no one has access to anything? The answer to that is you need to have a capability to temporarily grant access to complete a specific task. Let's just say that there is a new version of software that needs to be deployed. So the software is now sitting there ready for that deployment. So there needs to be a ticket, like ticket is created and assigned to like a DevOps team or a particular DevOps individual. And the ticket says, hey, Philip, we need to go and kick off deployment. So once the ticket is created, systems like Teleport, they should grant you access to that particular environment just to run that deployment and nothing else. And then once deployment is launched and it's complete, so then your access is automatically revoked. In this case, you're shrinking attack surface area also in time. That is also needs to be implemented. So again, zero trust by itself is not enough. You need to make sure that you get rid of all the secrets just to minimize the probability of breaches in the first place. Because not having secrets allows you to, it gives you scalable access. It means that as you add more and more systems, more and more servers, more and more engineers, you're not accumulating more and more secrets, which means that the probability of you getting hacked doesn't grow with scale. So if you go secretless, then the size and complexity of your infrastructure and the size of your team doesn't matter. So that's the first thing you need to do. Second thing, you need to have minimal required privileges. for your identities in general, but also in time. Privileges only need to exist when they're needed. And then finally, you need to have the zero trust capability that that prevents an attacker from pivoting. Those kind of three components together, they have to keep in mind. That's why all of this is important.
Okay, and maybe just sort of before we finish, it'd be good to understand, I suppose, the challenges of implementing or adopting a zero
Mm-hmm.
trust approach. But I guess the incentive, what the benefits that it can bring with it. And maybe if there's the sort of second part of that would be good to understand how Teleport sort of helps people with those challenges and also, helps them get to the benefit.
So I would actually say that there are very few organizations out there who implement zero trust fully and completely. Because remember, like full zero trust implementation essentially says that you can get rid of all of your firewalls, open up your network. In a true zero trust system, there is no difference between public network and private network. Go find me an organization that could safely say, we're opening up all of our firewalls. We're fully zero trust. That just pretty much never happens. So why is that? Again, there are numerous reasons. There is like obviously things like basically organizational obstacles like inertia, lack of expertise, not enough time and resources, because computing systems that we run, like they didn't show up yesterday. Like everything's been inherited. We have a lot of legacy systems. There is just a lot of things that have been kind of working. Let's not touch them. So that is always a factor, particularly with companies older than 5 years. Let's say this. So let's put this aside because it's true with any technology. It's not even zero trust related. But there are other kind of more specific technical challenges why implementing zero trust is hard. The first one is something I mentioned earlier. It's the segmentation of identities. Remember, for zero trust to work, you need to have a system, a zero trust system, that enforces that every connection is authenticated and encrypted. But that enforcement is not possible unless the identities of client and the server are well known. But because identities are siloed and fragmented, we don't really have, most organizations do not have a single system that keeps track of identities of everyone and everything. That prevents them from deploying zero trust globally, which means that you could do zero trust style connectivity for this particular silo of identities, but then you have to do it again for another silo and again for another silo. That creates a lot of work. So segmentation or siloing of identities is what slows down zero trust adoption. And the third reason is that there are some computing systems, primarily legacy systems, and not, by the way, that old, that are simply not compatible with zero trust. Remember that zero trust, every connection needs to be authenticated and encrypted. And unfortunately, we still have technologies that simply just don't support it. They maybe it's a web application that an engineering team built 15 years ago, and that web application made an assumption that it's running inside of a secure perimeter. There is no encryption. It doesn't even support it. So you cannot turn it on for that particular resource. So obviously you cannot employ zero trust in this case. Now, the second half of your question, like what is Teleport doing to address these challenges? Let's zoom into segmentation of identities first. So I think Teleport is the first and only system out there that makes a concentrated effort to consolidate all identities in one place. So Teleport keeps track of identities of all humans, the laptops that they're using, client devices, in other words, all the servers and virtual machines you have in data centers, and also the workloads, things like Kubernetes clusters, databases. So that essentially gives Teleport visibility into the full triangle of computing: hardware, software, peopleware. So we know identities of all three. So that allows us to give you easy zero trust implementation that breaks this identity silos. Now, the second problem that I was talking about, the legacy systems that don't even support encryption. For example, What do we do about those? So for those systems, we use technology called reverse tunneling. The way it works that you would put like a little teleport agent on a box where that system is running that's not compatible with zero trust. And what allows you to, and that agent, that teleport agent, it creates an encrypted tunnel from that, it's a network tunnel, from that particular machine into the zero trust proxy that teleport provides. So that tunnel is outbound and it's encrypted. It means that teleport uses its own mechanism to create the encrypted tunnel. And then you could shut down the networking on that machine. So then inbound network connectivity. So it's a machine. So we convert this machine into something that doesn't ever pick up the phone. You cannot dial, you cannot connect to that machine because it doesn't listen on the network anymore. However, the tunnel that teleport creates, that tunnel could be used for connectivity. So that gives you two capabilities. First of all, now you could connect to that resource, to that machine or that box, no matter where it is in the world. So if it's an IoT platform that's flying in the sky, because it calls back home and you could use that connection to manage it, to have access to it. So that's the first capability, that now you have this connectivity that's universal. But the second one is that now your application that's sitting inside that wasn't compatible with zero trust, now it suddenly is, because we provide identity, because we provide encryption, which now allows you to run that legacy workload on that particular platform. So that's kind of two things that Teleport does to dramatically simplify adoption of zero trust for our customers.
Okay, maybe just finally, I'm intrigued. I'm sure you probably had a go at understand it, but one of the major problems most companies face is application sprawl. They get more and more, and I know in security, I mean, I think last time I counted there were probably over 100 different kind of categories of security software. But if I've understood you correctly, what you are doing is potentially able to replace or help people consolidate a lot of that application. So is that another major sort of benefit and attraction, that people can get rid of quite a lot of other applications because what you're doing eliminates the need for those? Is that fair to say?
Well, I think what you said should be true for every useful technology. For example, when you, if you're buying something new, if you're adopting something, like, you have to get rid of something else, because otherwise, what is the point? Because otherwise, everything becoming progressively more and more expensive and more complicated. So if we to zoom into what is exactly Teleport is replacing and making unnecessary, before I answer that question directly, I want to make a clarification. I think when you look at all cybersecurity solutions, you could probably put them into kind of two categories. Category number one, and this by far the most numerous category, almost all cybersecurity solutions fall into that category. We call it the IT use case category. So like a good example would be something like Okta or Active Directory, which is like identity platform. So that identity platform provides identities and single sign-on capabilities for all of your employees. So that's something that IT would go and purchase and manage. So that's a solution that's built specifically for IT. So most of cyber is built for IT. But the second category is solutions that you would use in a data center. So this is for your infrastructure. This is for your DevOps team. This is for your kind of platform engineering teams, like the solutions they use. They are different than versus IT solutions. And the difference is, first of all, scale. So things you run in data centers and cloud environments, like you now looking at tens and hundreds of thousands, sometimes millions of servers and resources. So it's just like completely different scale. Secondly, things are much more automated. So instead of clicking on buttons and looking at screens, like you actually want like scripting, you want automation to help you, because that infrastructure itself is quite frequently software defined, right? Software defined infrastructure is the norm. So which means that you need to have software defined cyber for that infrastructure. And finally, there's this kind of workflow, like the way how DevOps teams operate, the way like their day-to-day operations is very different from how IT operates. So when I'm talking about Teleport displacing or replacing something, I am talking specifically about the infrastructure side of the house. So we're not claiming that we can come in and replace Okta, because Okta is for IT. Like that's not the kind of market, not the use case that we're playing with. We can integrate with Okta, so you can authenticate using Teleport, using Okta backend where all of your employees are stored. But we're focusing specifically on infrastructure access. And when we zoom into specifically into infrastructure access, we will you will see that first of all, people are trying to use IT-based solutions. For example, they would try to use PAM, privileged access management systems, to manage privileged accounts on their infrastructure, but they just don't work at that scale. So that's one thing we replace. You don't need PAM anymore for your infrastructure because Teleport can do that. Second thing we replace is something, systems like VPNs. Because VPN is essentially, it allows you to extend the perimeter from one data center to another or to your office. But Zero Trust says perimeters are obsolete. You should not trust your network. So therefore, if you adopt in Teleport, you no longer need VPN. We could provide connectivity, secure, encrypted, authenticated connectivity between any two agents anywhere in the world, between human and machine, between machine to machine, even if that's an IoT plot, like a drone flying in the sky, we support that as well. So that's the second thing you probably don't need. And I would just probably like stop there. So simply replacing VPNs, replacing privileged access management, and replacing any kind of homegrown kind of custom contraption that you might have. That is most common examples of what Teleport helps companies to kind of modernize and get rid of.
Okay, we covered a lot of ground, and it's a really fascinating topic, and you've explained it so well. I just enjoyed it, and really thank you for your time. I really appreciate it.
Well, thank you. It's great to be here.